Okay. I wanted to pick up where we left off with transforming graphs of sine and cosine, and also look a little bit at modeling, taking a true to life situation and modeling that. So that we can use that to then predict and find other values and things of that sort. So let me do that here real quick. There we go, that's better. The first thing though I want to do just to kind of practice is taking a look at your homework, your amplitude and period. I know there are a lot of these guys, but this is the kind of thing that when you're going to sketch a graph, you need to be able to pick out these things really quickly. Okay? In fact, you ought to get to the point where you could do like all 12 of these in, a minute or two. And that's how comfortable you need to be picking out your amplitudes and periods, especially amplitude. I mean, it's simply the number in front of the sine or cosine. And unless it's negative, you just use the numerical part. The negative, what does the negative do there?
It just makes
Reflects it.
Yeah, it reflects it. In this case with number 6, it reflects it across the x-axis. Okay? What?
Nothing. The others are still like always positive, right?
Amplitude and period are both always positive. Okay? So let's take a look through these real quick. Let's just do the amplitudes. Okay? So number 3, what's our amplitude? 3. Number 4?
2.
Number 5?
5/2.
Good, 5/2. Number 6? 3, yeah, there we go, no minus there. 7?
2/3.
Okay, 8?
3/2.
Good, 9?
2.
2, 10?
1.
11?
1/4.
12?
5/2.
5/2, good. 13?
1/3.
And 14?
3/4.
Okay, so that quickly we should be able to pick out our amplitude. And then when we're graphing them, if it's sine, we're going to start at wherever the origin was translated to, or start at the origin, and we're going to go up and down this many. Okay, when we're doing cosine, we're going to start that far above the origin. Okay, because normally cosine starts at 1. So, we're going to start it like on number 4, 2 cosine of 3x. We're going to start up at 2. You can actually see that here in the graph that they gave you. You're starting up at 2. Alright, so it's important to be able to recognize that real fast. What's the thing that we, we're going to use this 2 that's with the x and the 3 that's with the x and so on. How do we find the new period using that number?
Divide 2 pi divided by the number.
Okay, it's 2 pi divided by the number. So if we do 2 pi divided by 2, we get pi. And 2 pi divided by 3 is just
2 pi over 3.
Yeah, 2 pi over 3. That one would be fun. Figure out the other points for, but it still works the same. Okay, how about number 5?
Pi. Wait. 4 pi.
4 pi.
Oh, yeah.
2 pi divided by 1/2, because you're multiplying by 1/2 there. You flip and multiply, so that's 4 pi. Okay? How about number 6? X over 3.
6 pi.
Yeah, we're going to have 6 pi. Okay? How about 7?
2 pi.
Yeah, just 2. The 2 pi divided by pi is just going to be a period of 2 radians.
Would you then make your interval on the x-axis not based off of pi?
Yeah, you would label your x-axis just going from 0 to 2, and then actually finding your other points is really easy in that case. Yeah, it'd be 0.5, 1, 1.5, and 2. Yep. How about number 8?
1.
2.
4, there we go. 2 pi divided by pi over 2, you flip and multiply, the pi's cancel, and it's 2 times 2, so that's 4. Okay? Take a minute or two here and try 9 through 14. If you did it for homework, just double check. Okay? Double check your answer.
So if we get the period like 6 pi or 2 pi over 3, how can we graph the graph?
How would you graph the graph for like 6 pi?
No, 2 pi over 3.
For 2 pi over 3? Well, yeah, this one. I mean, they have it done for you, but what you would do is that's not translated at all. So we're going to start at the origin. We're going to end at 2 pi over 3. And then what you could do might make it a little simpler. Rather than trying to cut it in half and then cut each of those in half, divide that by 4. So you have 2 pi over 12, which is pi over 6, right? So each quadrant's going to be pi over 6. So here is pi over 6. Here's 2 pi over 6, or pi over 3. And then here's 3 pi over 6, or pi over 2.
Then how do
And then cosine starts at the top. So since our amplitude on that one was 2, we're going to start up here at 2, then hit 0, then go down to -2, then back to 0, then up to +2. And that would be one period of the graph. Okay? Alright, so let's work through these. Number 9, what's our period?
2 pi.
Yeah, it just stayed 2 pi. Number 10, 5 pi, alright? 5 pi. Number 11,
3 pi.
3 pi. 12?
8 pi.
Yeah, 8 pi. 13, it's 1/2. The pi's cancel out, and then you have 2 over 4, which is just a half.
24.
Okay. And the last one is 24. You end up multiplying by 12 over pi, you get 24. Okay? So, any questions about those? Now's the time to ask, because we need to be really comfortable doing this. This is like, the most basic part, other than knowing what the original sine and cosine are. Okay, so you've got to know that first, then you've got to pick out this, and then you can start thinking about any translations or reflections or whatnot. Okay? Alright. We're going to look some more at this in a little while, but I want to take a look at how to create models, and then as we do that, we'll also get some ideas to how these graphs are transformed and whatnot a little bit better as well. Here we have a situation, there are a lot of different natural phenomena that occur periodically. Okay, and the tide is one of those. Okay, if you track the depth of the water at any given place, you'll see tides come in and it'll be deeper at one part of the day and then it'll be shallow at another part of the day. You guys are familiar enough with that. But one thing that's helpful that some places will do, especially near a dock or something like that, is they'll track throughout the day what the depth of the water is going to be. Okay? Here it says throughout the day the depth of the water at the end of a dock in Bangor, Washington varies with the tides. The table shows the depths in feet at various times during the morning. So they start at midnight and they go to noon. And they just measure how deep the water is at the dock there. What we're going to do here, there's two parts. We're going to use a trig function to model the data, first of all. And then we're going to answer the question of, all right, we've got this boat that needs at least 10 feet of water to moor at the dock, or that means to just be connected to the dock so it doesn't drift away. During what times in the evening can it safely dock? All right, so we've got a couple of things going on here that we'll have to figure out. But let's first of all think through how we would do this problem.
The sine function.
The first thing is basically just pick either sine or cosine.
It doesn't matter.
It doesn't matter which one you pick, okay?
It goes up though, so wouldn't it be sine? Like,
Well, that's the cool thing about it. You can find it either way. The only difference will be one will be translated pi over 4 units over from the other one. Okay? I should say pi over 2. Sorry. Pi over 2 units from the other. So, I don't care what we use. What do you guys want to use? How many of you want to use sine?
Sine.
Alright? How many of you want to use cosine?
No.
Alright, the others don't care. So we'll use sine. Alright. So the question is, how do we find our amplitude and period? We're going to do sine, and the sine curve, we have y equals d plus a sine of bx minus c. Okay?
What do you did?
We need to find all of those parts. Okay, that's the general form that we looked at yesterday. We need to find all those different parts. So let's talk about how we would do that. And one thing you got to understand is you have to just go based on the data you have. Okay? If you look at our data, the highest point occurs at 4 a.m. and the lowest point occurs at noon. Alright, now, are we positive that those are the highest and lowest points?
no.
No, I mean it may have, what if at
4:30.
440 or something like that, it was a little bit deeper. We don't know. We would have to go out and measure continuously over, 12 hours or whatever in order to actually do that, or every 15 minutes or something to be more precise. But for our purposes, we can get a pretty decent model just based on this. So we're using the data we have and finding the max and the min. Yes?
With one cycle, would you have to skip for the PM times or no?
Well, that's a consideration that we have to make. You'll notice when they labeled their axis, they started where 0 was midnight. Okay? And what you would have to do is consider going on through a 24-hour time period. And then the next day would be 25 hours, 26, 27. I mean, you could translate it out, for days if you wanted to. Okay? But we'll just do one day here. Okay? Now, what?
Isn't it 12 hours?
What do you mean?
Midnight to noon.
Midnight to noon is 12 hours.
So that's how long it is?
Well, no, we're gonna actually look at that. Okay? Let's start out though with the amplitude. okay? The amplitude. That'll give us what A is. Alright? If I have a max at 11.3 and a min at 0.9, that's a distance of 10.4, right?
Yes.
So what's the amplitude?
Plus
5.2.
over 2, 5.2.
Okay, good. Good. We're going to do 11 minus 11.3 minus 0.9 and then divide that by 2. And that's going to give us A equal to 5.2. Okay? It's all one piece. Alright? So we know already our equation is going to be A equals 5.2 times sine, and then we need the other stuff. Okay? So, from the max to the min, if you look at your sine curve, it goes like this. You guys know this. From the max to the min, how much of the period is that?
That is half of it.
Half the period. So if I look at my times from 4 a.m. to noon, that's 8 hours, right? So what's the period?
8 hours.
16 hours. Okay? From 4 to noon is 8 hours. So that means my period is 16 hours. Does everyone get that? Okay, so our midline must have occurred, 4 hours, back, and our midlines are going to occur again 4 hours after this. Okay, we have a total of 16 hours for our period.
And then do you put like 2 pi reverse backwards to get the S?
Wait, what?
Because is it period 2 pi over B?
Yes. Okay, I didn't get what you're asking. Yes. Your period 16 is 2 pi divided by B.
So that means B's gonna equal.
Something 5. It's 1/8 pi.
0.8 pi.
Okay, yeah, 1/8 pi. All right,
Is Nick in the class?
Nick?
Can I borrow him for a minute?
Sure.
Thanks.
All right, if you solve this, you multiply by B, you have 16B equals 2 pi, you divide, and you get B equal to pi over 8. Okay? Does that make sense to everybody?
Yep.
All right? Some are kind of drifting. Make sure you pay attention. All right? So at this point, watch this. At this point, we now know the depth of the water, y, is going to equal 5.2 sine of pi over 8 times x. Now I need to figure out the translation. How far up was this sine curve moved, and how far over was the sine curve moved? Okay, so if this is the highest point and this is the lowest point, I can figure out where that middle is, right? How would I do that?
And subtract 5.2.
Average them, good.
Or couldn't you just subtract 5.2? Because we know the amplitude.
Yeah, you could do that too. Subtract the amplitude from the highest point. Either way, you'll end up getting 6.1. Okay? Now, be careful here because remember the translation, that 6.1, oh wait, yeah, this is moving up and down. So the 6.1, we would just add on to the end. Okay? So it's going to be plus 6.1. So we actually could say the average depth of the water is going to be 6.1 feet. Okay? Sometimes it'll be deeper, sometimes it will be shallower, but that's actually going to be the average depth. The kind of challenging thing is to find this one right here. This part right here. Okay? And you have to think again in terms of your period. If your period is 16 hours, okay,
Why is 60 hours?
because this was 8 and that's half the period, so it's 16 hours, alright? How far before 4 a.m. is our midline going to occur, the beginning of our period going to occur?
8 p.m.
I'd say about
No?
12. I mean, can you scroll up a little bit? It's probably about
6 p.m.
1. No. 12, 6:30. No.
That's 4.
What's a quarter of our period? 4 hours, right? So 4 hours before 4 a.m. would be midnight, okay? So that's hour 0, right?
But it's the depth is 3.1 then.
It does, and that's where, okay, we recognize that it's a little limited. According to our model, at midnight it's going to equal 6.1 feet.
6.1 feet.
It was only 3.1 feet, okay? So there is a limitation on our model here, okay? The reason is we aren't absolutely certain that this was the highest and that this was the lowest it got.
Okay.
Okay, that's why. But again, this is a model to help us approximate things. It's not always going to be perfect. Okay,
Where's the 6.1 concept?
the 6.1, it came from the fact that if this is the max and this is the min, sine, remember, starts, you know, it has that kind of midline there that that you go up to get the max, you go down to get the min, but this is where it would start and finish.
So you use
Right.
plus together divided by 2.
Yeah, we add those together and divide it by 2, or you could take the highest point minus 5.2. Either way, you get 6.1. Okay? Now, you don't have to put the minus 0 in there. Alright, but this does give us a good model. Y equals 5.2 sine of pi over 8 x plus 6.1.
I didn't get where did you get like in the period? Why is start from 4 to the end?
We just pick the highest and the lowest.
Oh, so every time we pick
From 4, yeah, and we're just going on our measurements, okay? We don't know for a fact those are the deepest and shallowest the water is, but that's just what we have measured, okay? So here's part A. We've got our model, and if we then use that, we can actually find depths at different times, okay? Where did I put my calculator? Where did I put the calculator? The Wabbit EMU calculator.
微暗是怎么算出来的？
二就是最高减最低。
Huh. Not sure what happened to that thing.
最高减最低。
最高减去最低，然后再除以
Oh wait, there it is.
2。
Okay. So let's bring up the calculator and get your calculators out as well, okay? First of all, what unit of measure are our angles in? Radians, okay? So if you go to your y equals, go to y equals and type it, or first of all, make sure that your units are in radians. And then if you put in this formula here that we just found, you should be able to then figure out how deep the water is going to be at different times. Okay, so I'm going to hit y equals 5.2
This actually looks pretty accurate.
5.2 sine, and I'm going to do pi times x, pi x divided by 8 to do my inside the sine. Close your parentheses, plus 6.1.
Oh, that didn't work.
Now, if we want to look at a full day, what should we set our window at?
24.
0 to 24, right? Okay? Before you graph it and then see it doesn't work real well, think, okay? We're going to go from 0 to 24. That'll give us a full day. Our y min, I'm going to set at 0 because obviously you can't have negative amount of water, okay? And then it's going to go from 0 up to, our max was 11.3. So let's make our max on our window be 12. Okay? And now you can hit graph. Yes.
Here's help me with something.
What's that? Oh, that's stat block. If you hit up and hit enter on that, it was highlighted. We already going to turn it off. Okay. All right, so here you see the graph. So now if you hit trace, let's say we want to figure out how deep the water was at 5 a.m. You hit trace and hit 5, and you see the depth was 10.9.
Can't you
Okay.
put another line that equals 10 and then just look for the points above that?
Oh, for part B, yes, you can.
Oh, we're still
Okay.
on part A?
Well, I'm just applying our model here, okay? Let's say I wanted to figure out how deep the water is going to be at 5 in the afternoon. What would I punch in?
X equals
Good, Ellie, 17. X equals 17.
8.9.
All right, so 8.0899 and so on, okay? That's how deep it'll be. So that's what this model is good for. Even though it's an approximation, we can get a decent idea of where it will be, okay? Or how deep it will be.
So like if you took a measurement early in the morning of one day, could you apply this to the model and figure out what it's gonna be like all day? Or would each day be different?
Well, on this one, given what we have, you'll see that, hang on, let me see what 24 equals. Okay, you'll notice 24, we're back to 6.1, okay? But we're on the way down. So in this case, because our period is only 16 hours, every day is gonna, this window of time is gonna kind of change, all right? So, but I mean, if we wanted tomorrow, we could make it like 35 hours or something. Just have it always go from today. Yes.
Can you check what would be the depth at 4:30 a.m.?
At 4:30 a.m. So we type in 4.5, 11.2.
How about 4:15?
It's going to be closer to 11.3. All right, but I want to get to part B here. We need at least 10 feet of water to get our boat in here. Okay, so there's only going to be a certain window of time that it's going to be possible. So what we're going to do, we've done this before. We can punch in a line, y equals 10. All right? And when we graph that, you can see there the time periods. The time periods when we're going to be able to moor the boat are going to be just this little window of time here and this little window of time here. Okay? And it asks during what times in the evening can it safely dock? So how do we find this? Intersect, okay? Remember, you doing intersections? All right, we're gonna do second calculate intersection. That's number 5. Our first curve is the sine curve. Our second curve will be the 10. And then we're gonna scroll over here close to the intersection point and hit enter. And we get 18.159. Okay? So yeah, that's like 6, just after 6 p.m. All right? Probably to be safe, we might wait till 6:30 or so. Okay? But 6 p.m. and then we could do that again. Intersect and scroll over here. And there's our guess. That's 21.8, which is, if it were 22, that would be 10 p.m. Okay? So,
It's about like 6 to 9:30.
yeah, so like just after 6 to almost 10, you know, to be safe, maybe 6:30 to 9:30 would be our window of opportunity to get that boat in and get it out. Okay?
I would just put it in and go at 7.
So, alright, so does that make sense?
Yeah.
Now we'll look at how to solve equations like this. If we set it equal to 10, you can solve it algebraically as well, and we'll look at how to do that. But, please have a seat. Okay? But that'll be kind of in the future here, alright? Does anyone have any questions?
When will the break?
0 is from that.
Sometime on the weekend.
I mean,